For this question, a ball is dropped from a height of 4 meters. We want to know how long it takes for the ball to hit the ground. So, if we visualize the situation, we're dropping a ball, starting here, it's going down 4 meters. So let's fill in what we know and what we don't know. What do we know? Well, it's dropped from a height of 4 meters. So our displacement is equal to 4 meters. Now we need a second to think here. If we're saying this direction is up, that's our positive direction, that means our displacement is 4 meters down. Acceleration due to gravity, when we ignore air resistance, is going to be negative 9.8 meters per second squared. One last thing we know is that it's dropped. If it's dropped, its initial velocity is 0. We're trying to find how long it takes to hit the ground. So we're trying to find the time. So we look in our equations and we see 1, 2, 3, 4 variables. Which 4 can we find here? This equation. So our equation, delta x is equal to vi delta t plus 1/2 a delta t squared. So now all we have to do is isolate for time. Now this is a little tricky. We've got time over here and time over here. So it's really helpful if we notice that our initial velocity is 0. So that means this entire quantity is going to be 0. Let me write that in. Delta x is equal to 0 plus 1/2 a delta t when the initial velocity is equal to 0. If we make this 0, the entire term is 0. So this is a little bit easier to solve for. We got to get the time all by itself. So what can we do to both sides to get time all by itself? Let's get rid of that 1/2 a. What I do to one side, I have to do the other. Now I have delta t is equal to delta x all over 1/2 a. Now I want to get rid of that squared. I want t all by itself. So if I want to get rid of the squared, I take the square root of both quantities. When I take the square root, this just gets me delta t. Alright, all that's left is to sub in your values. Square root negative 4 all over 1/2 negative 9.8. Put that in your calculator, you get 0.9 seconds.